In this video, we're going to talk about how to represent a function as a power series. So this is going to be the first example. Let's say the function f of x is 1 over 1 plus x. How can we write that as a power series? Well, first, you need to be familiar with a geometric series. Now, there's two forms that you might have seen it. Here's one form. A times r to the n is equal to a over 1 minus r. This is the sum of an infinite geometric series. Now sometimes you might see it in this form. So rather than starting at n equals 0, sometimes it may start at n equal 1. In that case, it's going to be in the form a times r to the n minus 1, where a is the first term of the series. And the sum is still going to be the same. Now r is the common ratio. And keep in mind, a geometric series will converge if the absolute value of r is less than 1. In this lesson, we're going to represent our power series starting from the n equals 0 value as opposed to the n equal 1 value. Now, a power series contains a variable x raised to the n power. So a geometric power series will be in this form, x to the n. In this case, a is 1, and so the sum for that is going to be 1 over 1 minus x. Notice that this formula looks very similar to that one. So therefore, this function should have a power series that looks somewhat like that, but not exactly like that. Now, this particular power series is centered at x equals 0. If you want to write a power series centered at x equals c, you can write it in this form. So it's going to be x minus c raised to the n power, where c is some number. So just keep that in mind. So let's start with this example. Right now, we need to write this function in the form of a over 1 minus r. So somehow we need to convert the positive sign to a negative sign. How can we do that? Now, it's important to know that a negative times a negative is a positive. So we can write it like this. 1 plus x is the same as 1 minus negative x. And so now it's in this form. So looking at this equation, what is a and what is r? So notice that 1 is equal to a and negative x is equal to r. So now that we have the a value and the r value, we can now write the geometric power series. So it's going to be in this form, starting from 0, going to infinity, a times r raised to the n. So this is going to be 1 times negative x raised to the n power. Now, negative x is negative 1 times x. So this is going to be negative 1 to the n times positive x to the n. And so this is our power series for this particular example. This is the answer. Now there's still a few more things that we need to do. The next thing is we need to find the interval of convergence. So how can we go about doing that? So recall that the common ratio has to be less than 1 in order for the geometric series to converge. Now we know that the common ratio is negative x. So therefore, the absolute value of negative x has to be less than 1. Now once you have it in this form, the absolute value of x minus c, it's less than r. In this case, c is 0. But r is going to be this number if there's no coefficients in front of the absolute value symbol. So therefore, r is the radius of convergence, and in this example, it's equal to 1. Now let's determine the interval of convergence. The absolute value of negative x is the same as the absolute value of x, because the absolute value of -1 is 1. And so now we can get rid of the absolute value symbol and say that x is between 1 and -1. And that is the interval of convergence. So what does that mean? Before we get into the answer of that question, let's plot the interval of convergence on a number line. So it's centered at 0, and it's from -1 to 1. So we have an open circle at the end because -1 and 1 are not included. So when dealing with a geometric power series, you do not need to check for the endpoints because it's always going to be parentheses. The endpoints will never be included. And the reason for that is due to the fact that the common ratio has to be less than 1 in order for the geometric series to converge. Remember, if it's equal to or greater than 1, then the geometric series will diverge. So the interval of convergence for a geometric power series will never include the endpoints. So you should always have parentheses and not a bracket. So this is our center, our x equals c value. And the radius of convergence is basically 1/2 of the interval. So in this case, the radius of convergence is 1. Now let's talk about what it means. So what does it mean that the interval of convergence is between -1 and 1? So recall that the function f of x, which is 1 over 1 plus x, it can be represented by the power series from 0 to infinity, -1 to the n, x to the n. Now let's write out the first 5 or maybe 6 terms in a series. So when n is 0, -1 to the 0 is 1, and x to the 0 power is 1. So the first term is 1. When n is 1, we're going to get -x. When n is 2, -1 squared is 1, and so it's going to be positive x squared. And then it's just going to repeat. So you can write out as many terms as you want to, and that's just going to it's going to go on forever. Now, this function can be represented accurately by this series only when x is between -1 and 1. So let's calculate the value of f of 0.5. So if you plug into your calculator 1 over 1 plus 0.5, or 1 divided by 1.5, you should get 2 over 3, which is 0.6 repeated. So I'm going to round that as 0.667. Now, let's use the power series to estimate the answer. And you want to choose an even amount of terms since we have an alternating series. So you want to use either like 6 or 8 or 10 terms, not like 7, 9, or 11, because your answer is going to be a little off. So I'm going to use the first 8 terms. So it's going to be 1 minus 0.5 plus 0.5 squared minus 0.5 cubed plus 0.5 to the 4th minus 0.5 to the 5th plus 0.5 to the 6th power, and then minus 0.5 to the 7th power. Go ahead and take a minute to type that in your calculator. The more terms that you add, the more accurate your answer will be to the true value. So stop it at negative 0.57. I got approximately 0.6641. So 0.6641 is a good approximation of 0.667. So we can use a geometric power series to represent almost any rational function in the form of a polynomial. Now let's work on some example problems. So let's say that f of x is 1 over x. Go ahead and represent the function as a power series and find the interval of convergence. So the first thing we need to do is we need to put it in this form, a divided by 1 minus r. So right now we're missing a 1. So how can we introduce a 1 into the denominator of the fraction? So when you're adding new numbers into the picture, you cannot change the value of what was there. So in the bottom, the value is equal to x. Now we can add 0 to x. 0 plus x is still x. But adding 0 won't help us. However, 1 plus negative 1 is equal to 0. And so that's what we're going to add to the bottom of the fraction, because the value of the fraction will still be equal to x. Now I need a negative sign between 1 and r. So I'm going to move this 1 to the left side. So right now I have 1 plus x minus 1. Now I need to turn the positive sign into a negative sign. How can I do that? The best way to do that is to factor out a negative 1 as your greatest common factor. And so it's going to be, if we take out a negative from positive x, we're going to get a negative x. And then if we take out the negative sign from negative 1, it changes to positive 1. And so this is what we have. So now it's in the right form. So notice that a is equal to 1 and r is equal to negative x plus 1. So now that we have a and r, we can write the geometric power series. So let me get rid of this. So now let's use this expression. And then all we need to do is replace a and r, and then we could simplify it. So a is 1, we can ignore 1. You don't have to write 1. So we're going to have the summation symbol, and then r to the n, which is negative x plus 1 to the n. Now, can we leave the answer like this? When representing a function as a power series, you want to write it in this form, x to the n, or you want to write it in this form, x minus c raised to the n. So right now we have negative x and not positive x. So therefore we're going to have to factor out a negative 1 inside the parentheses. So this is going to be, let me use brackets. So we're going to have brackets, negative 1 times positive x, and then positive 1 will change to negative 1. And this is all raised to the n power. Now I'm going to distribute n to the negative 1 on the outside and x minus 1 on the inside. So this is going to be negative 1 to the n power times x minus 1 to the n, starting from n equals 0, going to infinity. So this is the answer. That's the power series that corresponds to the function 1 over x. Now we need to find the interval of convergence. We need to know the x values where 1 over x can be represented by that particular power series. So notice that this power series is centered at x equal 1, because if you plug in 1 for x, you're going to get 0. So we can say that c is equal to 1. Now what else do we know? We know that the common ratio of the geometric series is negative 1 times x minus 1. And we need to write that because it's going to help us to find the interval of convergence. That's our next step. So for any geometric series, the absolute value of r has to be less than 1 in order for it to converge. So in this case, the absolute value of negative 1 times x minus 1, that has to be less than 1. So the absolute value of negative 1 is 1, so we could just ignore that number. So now we have this expression, which we can write this as x minus 1 has to be less than 1 but greater than -1. So if we add 1 to both sides, x is less than 2 but greater than 0. And so the interval of convergence is from 0 to 2. And you could see that c is 1. 1 is the midpoint of 0 and 2. The radius of convergence is basically this number that you see here when you have it in the form of the absolute value of x minus c is less than r. So the radius of convergence is 1. So plotting it on a number line, we have 1 at the center and 0 and 2 at the end. And keep in mind, 0 and 2 is not going to be included for a geometric power series. It converges between 0 and 2, but at 0 and 2, the series diverges. So this is our c value, and this is r. Now let's try another example. So let's say we have the function 1 divided by 1 minus x cubed. Go ahead and represent the function as a power series. So this function is already in the appropriate form. So we could see that a is equal to 1, and the common ratio r is equal to x cubed. So we can write the power series using this expression. So we have the summation from 0 to infinity, and this is going to be 1 times x to the third raised to the n. So we can write the final answer like this. It's going to be x to the 3n. Now, if we decide to list out a few terms, when n is 0, x to the 3 times 0, that's x to the 0, so that's going to be 1. And then when n is 1, it's going to be x cubed. When n is 2, 2 times 3 is 6, so x to the 6, and so forth. And so this power series is equal to 1 over 1 minus x cubed for certain x values. And those x values will be based on the interval of convergence. To find the interval of convergence, start with this expression. The absolute value of the common ratio is less than 1. And we can see that the common ratio is x cubed. So we could say that the absolute value of x cubed has to be less than 1. So thus x cubed has to be between 1 and -1. Now, if you take the cube root of each side of the inequality, you're going to get x is between 1 and -1. Therefore, the interval of convergence is just -1 to 1. And that's it for this problem. The next problem is going to be a little different than the last one. In this example, we're going to have the function 1 divided by 3 minus x. And we're going to do two things. Let's write the representation of this function as a power series, where it's centered at 0 and when it's centered at 1. Now keep in mind, when it's centered at 0, you want to put it in this form, x to the n. But when it's centered at some other number, you want to put it in the form x minus c raised to the n. So let's start with c equals 0. And let's put the fraction in this form. So notice that we have a 3. Somehow we need to change that to a 1. So what we need to do is multiply the top and the bottom by a third. So we're going to have 1/3 divided by 1 minus x over 3. And so now it's in the appropriate form. So we could see that a is equal to 1/3 and r is equal to x over 3. So writing our answer in this form, it's going to be 1/3 times r, which is x over 3 to the n. Now let's simplify the expression. So 1 over 3, that's just 1 over 3 to the first power. And now let's distribute the exponent. So this is x to the n divided by 3 to the n. And now we can combine these two into a single number. So let's add the exponents, 1 plus n. So this is going to give us the power series, x to the n divided by 3 to the n plus 1, from 0 to infinity. So this is the answer. Let's find the interval of convergence for this problem. And let's start with this expression. Now we said that the common ratio is x over 3. So therefore the absolute value of x over 3 has to be less than 1. And let's take out the 3. So this becomes 1/3 absolute value of x is less than 1. And now our next step is to multiply both sides by 3. And so the absolute value of x is less than 3. Now once you have it in this form, you can identify the radius of convergence. So the radius of convergence is equal to 3. And x is between 3 and -3, centered at 0. So the interval of convergence is from -3 to 3. And so this is the second part of the answer. Now let's go back to the original function, 1 divided by 3 minus x. And let's write the power series representation when c is equal to 1. So we need to put it in this format. That is x minus c raised to the n. And so that's going to be x minus 1 raised to the n power. Some sort of variation of that. So the first thing we need to do is get the x minus 1 term. So how can we get an x minus 1 expression in the denominator? How can we introduce it? And notice that we need the negative sign to be in front of it as well. So if we distribute the negative sign, this is negative x plus 1. Somehow we got to take a 1 from the 3. So let's break down 3 into 2 plus 1. So we have 2 plus 1 minus x, which is the same as 3 minus x. So whatever changes you do, make sure that the value of the fraction remains the same. So now I'm going to write this as 2 minus x plus 1. So I haven't changed the value. The only thing I did is I moved the 1 to the right. Now the next thing I'm going to do is take out a negative 1 from negative x plus 1. If I do so, negative x becomes positive x, and positive 1 becomes negative 1. So now it's centered at x minus 1, and the value is still the same. 2 minus x minus 1, this whole thing is still equal to 3 minus x. Now it's almost in this format. The next thing we need to do is change the 2 into a 1. And so to do that, we're going to multiply the top and the bottom by 1/2. And so this is going to be 1/2 divided by 2 times 1/2, that's 1. And then this times 1/2, so I'm going to write it like brackets 1/2 and then parentheses x minus 1. Do not distribute the 1/2 to x minus 1. The x minus 1 part is your x minus c term. Now it's in the appropriate form. So we could see that a is 1/2. So let's write that down. And what is the common ratio in this example? The common ratio r is 1/2 times x to the minus 1. So now that we have that, let's get rid of this. And let's determine the interval of convergence first. So let's start with this expression. So that means that the absolute value of 1/2 times x minus 1 has to be less than 1. So taking the 1/2 to the front, so we have this 1/2 x minus 1 is less than 1. So we need to multiply both sides by 2. So the absolute value of x minus 1 is less than 2. So now it's in this form. And so the radius of convergence, we can clearly see that it's equal to 2. So now let's get rid of the absolute value expression. So we're going to have that x minus 1 is less than 2 and greater than negative 2. So now let's add 1 to all three sides. And so x is less than 3 but greater than negative 1. So the interval of convergence is negative 1 to 3. Now let's plot it on a number line. So it's from negative 1 to 3, and our c value is the midpoint of those two values. So c is 1. So this is where x is equal to c. And so the geometric power series will converge anywhere where x is between negative 1 and 3. So now let's go back to our original function. And so this function, centered at c equal 1, can be represented by this particular geometric power series. Right now this is the geometric series, but once we replace r with x, then it becomes a geometric power series. So a is 1/2. R is going to be 1/2 times x minus 1 raised to the n power. Now this 1/2 outside of it, we can write it, I'm not sure what just happened there, but we can write it like this. It's going to be 1 over 2 to the first power. And then the n, we're going to distribute to the 1/2 inside the brackets and the x minus 1. So it's going to be times 1 over 2 to the n times x minus 1 raised to the n power. So we can write the final answer like this. It's going to be from 0 to infinity, x minus 1 raised to the n divided by, and these two we can combine and write it as a single 2. So 2 to the n plus 1. So this is the series for 1 over 3 minus x, where the series is centered at 1. And you can see the x minus 1 term. Now that you've seen how to do the last example, you should be able to do the next one. Consider the function f of x is equal to 8 over 2x minus 9. Now what I want you to do is write a power series representation for this function, and this time we're not going to center it at 1, but let's center it at 3. So go ahead and try this problem. So if we're going to center it at 3, we need the expression x minus c or x minus 3. And notice that there's a 2 in front of the x. So thus we're going to have 2 times x minus 3. And if we distribute the 2, it's going to be 2x minus 6. Somehow, we need to get a negative 6 into this expression. There's two ways we can do this. We can add negative 6 and add plus 6 to the bottom of the fraction. Or we could just break down negative 9 as negative 6 and negative 3. So let's just do it this way for now. So this is going to be equal to 8 divided by 2x minus 6 minus 3. Now since I wanted to put it in the a1 over 1 minus r form, I need x to be on the right side, not on the left. So I'm going to move the negative 3 to the left side. Now this becomes 8 divided by negative 3 plus 2x minus 6. So now the next thing I need to do is take out the 2 and get x minus 3. In addition, I need to get rid of the positive sign. So recall that a positive number is the multiplication of two negative numbers. So what I now have is 8 over negative 3 minus, now I'm going to take out, right now I'm just going to write it like this for now. So I didn't take out the 2 yet, but these two negative signs, they will cancel to make a positive sign. So these two expressions are equivalent as of now. Now I'm going to take out the 2 from 2x minus 6. So this is going to be negative 2 times x minus 3. Now the next thing I need to do is change this number. To put it in a over 1 minus r form, I need this to be a 1. So I got to multiply the top and the bottom by what number? I need to multiply the top and bottom by negative 1/3. And so this is going to be negative 8 over 3. Since I'm running out of space, I'm just going to put this at the top. So it's negative 8 over 3 on the top. And then we have negative 1/3 times negative 3, which is positive 1. And then minus, let's keep this negative sign. Let's not change it. And then negative 2 times negative 1/3. That's going to be inside the brackets, but positive 2 over 3. And then times x minus 3. So as you can see, it's now in the appropriate form. So we can clearly see that a, the first term, is 8 over 3, negative 8 over 3 that is. And the common ratio is everything inside the brackets, 2/3 x minus 3. As soon as you identify a and r, you don't need this equation anymore. So now let's write the geometric series. So a is negative 8 over 3 and r is 2 over 3 x minus 3, and we're going to raise r to the n power. So this is the answer, but we need to clean it up a bit. How can we simplify this expression? Now the first thing we have is a negative sign. So I'm going to write that as negative 1 for now. And then we have an 8. Notice that 8 and 2, they share the same base, a common base of 2. So I'm going to rewrite 8 as 2 to the 3rd power. And the 3 on the bottom, that's going to be 3 to the 1st power. And then everything inside the brackets, I'm going to distribute the exponent n to it. So this will become 2 to the n power divided by 3 to the n power. And then times x minus 3 to the n power. So we can write the final answer from 0 to infinity, and then negative, here we have 2 to the 3rd times 2 to the n, so we're going to add 3 and n, and just write that as n plus 3 times x minus 3 to the n divided by, and here we have 1 plus n, or n plus 1. So it's divided by 3 to the n plus 1. So this is the power series representation of our original function, which was 8 over 2x minus 9. And this is true when it's centered at 3. And we can see 3 in our expression, x minus 3, which tells us that it's centered at 3. The only thing we need to do at this point is find the interval of convergence. So as always, let's start with this expression. So r is 2 over 3 times x minus 3. Now let's remove the 2/3 from the absolute value expression. To get rid of the 2 over 3 on the left side, we need to multiply both sides by 3 divided by 2. And so on the left, the 3's will cancel, and the 2's will cancel. So now we're going to have the absolute value of x minus 3 is less than 3 over 2. So now it's in this form. X minus c is less than r. So the radius of convergence, we can clearly see that it's 3 over 2. And now let's get rid of the absolute value expression. So x minus 3 is less than 3 over 2, but greater than negative 3 over 2. So once you get rid of the absolute value expression and you write it like this, all you need to do is solve for x. So we're going to add 3 to both sides. Now, 3 plus 3 over 2. We need to get common denominators. 3 is the same as 6 over 2. So we're going to add 6 over 2 to all 3 sides. So these will cancel. 3 over 2 plus 6 over 2. 3 plus 6 is 9, so this is going to be 9 over 2. And negative 3 plus 6 is positive 3. So that's positive 3 over 2. So as a decimal, you could say that the interval of convergence is between 3 over 2 and 9 over 2. 3 divided by 2 is 1.5, and 9 divided by 2 is 4.5. So anywhere between 1.5 and 4.5, the power series will be a very good representation of the function. In fact, it's going to be an exact representation of the function. Anywhere outside of that, the power series will diverge. Now let's plot the interval of convergence on a number line. So we said it's between positive 1.5 and 4.5. And it's centered at c equals 3. The radius of convergence is 1/2 of the difference between 4.5 and 1.5. And so we said r is 3 over 2, which is 1.5. And so that's the distance between 3 and 1.5. And it doesn't include the endpoints. So the interval of convergence is between 1.5 and 4.5, but it does not include 1.5 and 4.5 itself. And so that's it for this problem. Consider the next example. F of x is equal to x cubed divided by x plus 2. So what do you think we need to do for this problem in order to write the power series representation for that function? Notice that it doesn't appear to be in this format. A is a constant, but we have a variable in the numerator. So for this particular example, what do you think we need to do? What we need to do is separate the function into 2 parts. So we can write this as x cubed times 1 over x plus 2. And so we're going to write the power series representation of this part first. So let's focus on that. Now we need to put x on the right side. So right now what we have is 1 over 2 plus x. And we need a negative sign. And we're going to write the function where it's centered at c equals 0. If it's not specified, always assume c equals 0. Now we need to convert the positive sign into 2 negative signs. So 2 plus x is going to be 2 minus negative x. Now the last thing we need to do is multiply the top and the bottom by 1/2. So this becomes 1/2 over 1 minus negative x times 1/2. That's going to be negative x divided by 2. So now this is in this form. So we could see that a is 1/2 and r is negative x over 2. So at this point, we can write the power series representation for this expression. So it's going to go from 0 to infinity, and then it's going to be a, which is 1/2, times r to the n power. So this is 1 over 2 to the first power, and then if we distribute the n, it's going to be negative x to the n power divided by 2 to the n power. So let's simplify that. Negative x to the n power. We can write negative x as negative 1 times x, and they're both going to be raised to the n power because the negative was on the inside of the parentheses. And then we can combine these two. So that's going to be 2 to the n plus 1. And so this is equal to 1 over x plus 2. Now, if 1 over x plus 2 is equal to this series, then f of x, which is x cubed times 1 over x plus 2, that's going to be x cubed times the power series that we have up there. At this point, all we need to do is multiply x cubed by x to the n. And so we're going to add 3 plus n. So we're going to get the power series from 0 to infinity of negative 1 to the n times x raised to the n plus 3 divided by 2 to the n plus 1. So this is the power series representation of x cubed divided by x plus 2. So sometimes you need to break down a function into two separate parts and then just multiply the other part if you can combine it with something in this expression. The last thing we need for this particular problem is the interval of convergence. And earlier in this problem, we said that r is equal to negative x over 2. And we know the absolute value of r has to be less than 1 in order for the geometric series to converge. So the absolute value of negative x over 2 has to be less than 1. Now we can break this apart into two absolute value expressions. Negative x over 2 is basically negative 1/2 times x. And the absolute value of negative 1/2 is positive 1/2. So we have 1/2 times the absolute value of x, which is less than 1. Now let's multiply both sides by 2. And so the absolute value of x is less than 2. And so this is the radius of convergence, which is 2. And to get rid of the absolute value expression, we could say that x is less than 2, but greater than negative 2. So the interval of convergence is from negative 2 to 2. And so that concludes this problem. That's all we need to do. Let's work on one more problem. So consider the function 3 divided by x squared plus x minus 2. What do we need to do for this example? For this particular rational function, the first thing we need to do is factor the trinomial in the denominator of the fraction. So x squared plus x minus 2. If we find two numbers that multiply to negative 2, but add to the middle coefficient of 1 in front of x, that's going to be positive 2 and negative 1. So it factors to x plus 2 times x minus 1. 2 times negative 1 is negative 2. 2 plus negative 1 is positive 1. Now, we need to split this fraction into two smaller fractions. And so we need to use partial fraction decomposition. So we're going to write this as a over x plus 2 plus b divided by x minus 1. Now, let's multiply both sides of the equation by the denominator on the left side. So that is by x plus 2 and by x minus 1. So these will cancel. Therefore, on the left side, we're just going to get 3. And then once we multiply these two, the x plus 2 terms will cancel, leaving behind a times x minus 1. And then when we take b over x minus 1 multiplied by these two factors, the x minus 1 factor will cancel, giving us b times x plus 2. Now let's see what happens when x is equal to 1. When x is equal to 1, a times x minus 1, that becomes 0. So we have 3 is equal to b times 1 plus 2, which means 3 is equal to 3b, and so b is 1. And when x is negative 2, we have 3 equals a times negative 2 minus 1 plus b times 0. And so this is going to be negative 3a equals 3, and so a is negative 1. So therefore, f of x can be written as negative 1 over x plus 2 plus 1 over x minus 1. So we said that a is negative 1 and b is 1. Now let's write the power series representation for each of these two fractions separately. So let's start with 1 divided by x minus 1. So the first thing I would do is reverse x to negative 1. So this is 1 over negative 1 plus x. So we need to get it in this form. Now, what I would recommend doing is multiplying the top and bottom by negative 1. So it's negative 1 over 1 minus x. And now it's in the appropriate form. So we could see that a is negative 1 and r is equal to x. So thus we can write the series as a, which is negative 1, times r, which is x raised to the n. And so we can leave it like that. Now for the interval of convergence, we know that r has to be less than 1 and r is x. So x is between 1 and negative 1. So for this series, the interval of convergence is between negative 1 and 1. Now for the other one, 1 over x plus 2, we did that in the last example before we multiplied it by x cubed. And so for that example, we had the series, it was negative 1 to the n times x to the n over 2 to the n plus 1. So we don't need to redo this again. And the interval of convergence for this one, we found it to be negative 2 to 2. Now, when combining two series together, if you're adding or subtracting them, you need to find the intersection of these two intervals. So, at what x value will both intervals be true? It's going to be true for the more restrictive interval, that is from negative 1 to 1. So this is going to be the interval of convergence for the entire problem. Because let's say if you plotted both answers. So here's the first one. This is for 1 over x plus 2. And for the other fraction, 1 over x minus 1, the interval of convergence is more restrictive. So for the combined function, we need to choose the region of the two number lines where it's both shaded. Notice that it's shaded between -1 and 1 for both number lines. And so that is the intersection of the two intervals. So therefore, the interval of convergence for the original function will be from -1 to 1. It has to be true for each individual fraction. Now let's put this all together. So the original function, we broke it down into -1 over x plus 2 plus 1 over x minus 1. Now the power series representation for 1 over x plus 2, we said that's -1 to the n times x to the n over 2 to the n plus 1. And for 1 over x minus 1, we found it to be -1 times x to the n. Now this negative, I'm going to move it inside the expression. So I'm going to move the -1 to the front, so to speak. So this is going to be -1 to the 1 power times -1 to the n. The only reason why I chose to move it here is to combine it with -1 to the n. Now this negative, I'm going to move it outside because it doesn't have an n power to it. So this is just going to be minus x to the n. Now I'm going to combine these two power series into one power series. So notice that I can factor out x to the n. So let's take that out. And then -1 to the 1 times -1 to the n, you can combine that as -1 to the n plus 1. And then divided by 2 to the n plus 1. And since we factor out x to the n, we're going to be left with a -1 out here. And so this is going to be the power series representation for the original function. So this is the answer, and the interval of convergence is -1 to 1, which means the radius of convergence is going to be 1/2 the difference between the two extremes. So 1 minus -1, that's 2, so half of 2 is 1. So the radius of convergence is 1 in this example. And so now you know how to write a power series representation for a problem where you have to use partial fraction decomposition to split it into two parts.